Today we will solve one question whose source I have already put it. Okay. So what's that? This is a combination of lenses. Okay. A convergent lens, a convergent lens, a convergent lens, and a divergent lens, and a divergent lens. Both are given to you, right? Now, what's given in what the is data given into the question? A convergent lens of power 8 diopter. So the power of this convergent lens is 8 diopter. So first of all, you need to understand what is a convergent lens and what is a divergent lens. Okay. So we'll come to that. So before that, I just write the data given into the numerical. Okay. A convergent lens of power 8 diopter and combined with a divergent lens of power minus 10 diopter, right? So you should know that a convergent lens is a convex lens, right? This is a convex lens. This is a convex lens, right? And a divergent lens, this is concave lens. So this you should remember the name that means convex, convergent, convex. You can see CON. And for divergent, make remember concave, right? Now it's given that what is the we need to find what is the power of this combination, and what is the focal length of this combination. What is the focal length? F equal to what? That need to be calculated, right? So this is a combination of lenses, right? So here it will be like this, a convex lens. Let's draw it. This is a convex lens, right? And along with this, a concave lens is present. Let's say like this. So this is a concave lens. Because you can see the depth here. So this is the convex plus concave arrangement. For this arrangement, we need to find the total power and focal length of this entire combination, right? This is what here we know the power of the convergent lens, that is convex lens, is given as 8D. That means 8 diopter. So for this lens, this is 8 diopter, right? And for the second one, that is the divergent lens, concave lens, it's minus 10 diopter. This is minus 10 diopter. This data is given to you into the question. Now we need to find the power of the combination. So for the total power of this combination is can be given as P1 plus P2, where P1 is the power of one of the lens and P2 is the power of another lens. So if 8D is the value of P1, right, and minus 10D is the value of P2, then P will be equal to this 8D and minus 10D. 8D, that is 8 diopter, plus minus 10 diopter. This will give you the value of total power of this combination, right? So this will give you, 8 minus 10 is minus 2D, right? So minus 2 diopter is the value of total power. So the power of this combination is calculated as minus 2D, right? Now what we need to calculate? The focal length. But we need to calculate the focal length. And you know that a focal length, the focal length of a lens is given as focal length, focal length of any lens or a combination of lens is given as reverse of the power of that lens or the combination of power. So the combined power of this arrangement of a convex lens and concave lens we have calculated as minus 2d, right? So the focal length will be calculated as 1 by p, and what is the value of 1 by p? It's 1 by, just put up the value of p as minus 2, right? This will give you the value of whatever the value, the unit will be in meter, right? So this will give you minus 0.5, minus 0.5 meter. So this will be the value of your f, that is focal length. So this is the focal length which we have calculated, right? So the second part is solved down, that is minus 0.5 meter, right? So for any such questions, students, take care that whatsoever be the lens, whether it's a concave, convex, or there can be n number of lenses. So to calculate the total power of this combination, just add up the values of those individual lenses power to get the final and total power of this entire combination, right? So you will get the value of power of those in that combination. And for the focal length, for the focal length you can calculate it just 1 by p, that is reverse of that power will give you the focal length, right? And that value is minus 0.5 meter we have calculated, right? So in this way such questions can be solved very easily, right? Yeah. Now let us come to the comment box. For any query we can discuss now. Yeah, for any query you can put up into the chat box and comment box. We will discuss. Right? Yeah, you can put up. So here what was the question? A question was that here the question was that a convergent lens of power 8D and a divergent lens of power minus 10D, both of these lenses, convergent lens and divergent lens, we are put together, and for the and like this, let's say like this, and for this combination we need to calculate the power and focal length of that combination, right? So if the p1 is the value of this convergent lens power, that is 8d, let's say it is p1, let's say this is p1, and minus 10d is the value of second lens, divergent lens, concave lens. Let's say this is p2, right? If this is p1, if this is p2, then the total power of the combination, right? This is the power of combination. Combination means both of them attached together, both of them attached together, right? And this will give you the value of power. Just add the value of P1 and P2. This P1 and P2, just put up the value of P1 and P2 here and just add it. This will give you minus 2D. So minus 2D is the value of power of this combination. Okay, and reverse of that will give you the focal length, right? So the focal length is calculated as 1 by p, which is equal to minus 0.5 meter, right? If you think it helps you, you can like it. Thank you so much. Yeah, so we have solved this question, students. So any query you can put up into the comment box. Yes, so this was very easy question, but such objective questions are coming into the examination, and you can solve it very easily. Yeah, thank you.